All right, guys, let's talk about lesson 3, which is factors that affect solubility. Number 1, the nature of the solute and the solvent. So, what does that mean? That means, for example, we're going to remember the phrase like dissolves like. So, if a substance is polar, okay, they will also dissolve in substances that are polar. Okay, when we talk about polar and nonpolar, we're going back to Unit 8, which was bonding. Remember, if something is polar, that means that it is not symmetrical. It's an asymmetrical molecule. Something that is nonpolar is a symmetrical molecule. So like dissolves like. So polar substances dissolve in other polar substances, and nonpolar substances dissolve in other nonpolar substances. So nonpolar, nonpolar, they will dissolve and they'll mix together. If they're both polar and polar, they will also mix together. So like dissolves like. Like nature, like polarity will dissolve in the same polarity of the molecule. So, unlike substances, do not dissolve. So, for example, oil is a nonpolar substance and water is a polar substance, so they do not dissolve. They will not mix. They will actually layer. Temperature is another thing that will affect. So, if you increase your temperature, your solubility will increase. So, for example, if you were to put sugar in water, to get that sugar to dissolve in that water faster, you would heat up your water. Why? When you heat something up, think about what happens. This is talking back to the beginning of the year when we talked about temperature and how it affects particles. It's kind of like a review. When you increase the energy or you add heat that is required to break the bonds holding the molecules in the solid together, what you're doing is you're allowing for those water molecules to circulate and come around those sugar molecules and pull them into solution. Remember, sugar molecules like to be next to one another in a crystal. That's why they're attracted to each other. And they like to be in that solid crystal very much so and very tightly compact towards each other. What happens when you heat them up is that you're allowing for water molecules to come in. And when you heat them up, the spaces in between the molecules will increase. And you allow for the water to come in and pull those sugar molecules into solution. Temperature of a gas is the opposite, actually. As you increase the temperature, your solubility will decrease. So what happens? Think about this. When you have a warm soda and it heats up outside, what happens to it? Well, it goes flat. This is because when you have a higher temperature, you increase the kinetic energy of the movement, which breaks the intermolecular forces that and allows for the molecules to escape from the solution as a gas. So what will happen is that the intermolecular forces that are holding those molecules close together are going to become less and they're not going to be as strong. And so that gas will leave. And that's why your soda becomes flat. Pressure will change your solubility for solids and liquids. As pressure changes, solubility does not change. Pressure for a gas, however, is different. As pressure increases, your solubility will increase. You're going to force more of those gas particles into solution just by adding pressure into them. What factors, now we're going to talk about the factors that affect the rate or speed of dissolving. So surface area. As your surface area increases, the rate of dissolving, example, sugar granules versus sugar cubes, okay? It's going to take a sugar cube a lot longer to dissolve than granules because the granules are smaller clumps of sugar molecules, and so the water's going to be able to get around these very fast. It's going to take a long time for these red water molecules to get anywhere near those inner sugar molecules, so they're going to take a lot longer to dissolve because they have a larger surface area as opposed to the granules, which have a smaller surface area. Stirring. If you stir something when you're trying to get something to dissolve, that will increase the rate of dissolving. So that will allow for more of the solute to become in contact with the solvent a lot faster and will get that solvent to pull those solute molecules into solution. So let's do a check your understanding. There's no real practice problems for this, so we're going to straight to a check your understanding. So what type of substance, a polar substance or a nonpolar substance, would CBr4 dissolve in? We'll talk about this tomorrow.